in maintaining the long-term relationship with customer, clients, and prospects. Then we do provide effective support by phone, email, or online. And we also have dedicated representatives account for each. And lastly, we support materials. We provide support materials like training videos, demonstration files, and quick start guides. So today we'll be dealing with the Automation Studio Educational Edition. So before moving forward, here are some key milestones achieved by Famic Technologies. So as mentioned before, we laid our founding stone in the year of 1986. And in the year of 1989, we were then known as HydroSim and NeoSim. And in 1996, we came up with a flagship product that is Automation Studio version 1.0. And as you can see later on, the progress was made down the line, taking into consideration the feedbacks from industrial experts, not only industrial experts, professionals, but also from the vocational institutes, educational institutes, universities, various colleges, and so on. And in the year 2024, we basically came up with the Automation Studio version 9.0, in which we have launched two new libraries, one being instrumentation and process control, and the second being robotics. So moving forward, now talking about what actually is Automation Studio software. So this particular slide is of much more important to us. Okay. So what basically is Automation Studio software? Automation Studio software is nothing but a multi-user collaboration sharing platform in which the user can not only just simulate or animate their circuit, but also they can take part in trade-oriented system design, and also they can perform machine documentation part. So we have bifurcated the Automation Studio software into three segments over here. When it comes to simulation and animation, so students and faculties can create their hydraulic circuits from scratch, mechanical circuits, electrical control circuits, electrotechnical one line, digital electronics, and then instrumentation and process control, then robotics. And coming on to the PLC ladder, so we can see we have PLCs ranging from Allen Bradley, Siemens, IC Electric, Mitsubishi, Omron, and so on. And lastly, we have the block diagram math. So this was all regarding the simulation and animation part. Now coming on to trade-oriented system design. So faculties can basically link their trainer kits with the help of the CAN bus, that is OPC client server, open platform communication, with the help of their software, that is Automation Studio. So Automation Studio software will be running behind the screen, and all the mechanical orientation of the components will be taken live, and that can be performed with the help of the OPC CAN bus. Now, when it comes to sequential flowchart, so we do offer SFC, then ladder logic, workflow, API script language, and failure maintenance as well. So these all technicalities are covered under trade-oriented system design. Now, the one of the most prominent feature of the Automation Studio is machine documentation. So over here, we have a prominent feature, that is catalogs, manufacturer's catalog. So which basically is nothing but pre-configured, ready to simulate components will be readily available on the Automation Studio software. The student just need to drag and drop those components in the Automation Studio software, and those components will be ready to simulate. Okay. I will be talking regarding this in much more depth in upcoming slides. With that being said, we also offer bill of materials, that we call it as BOM in industrial term, and students can also generate their own reports with the help of software. And we do provide component sizing sheets, then energy consumption, and we also offer the pneumatic circuitry part and hydraulic manifold blocks as well. So this was all regarding the Automation Studio software, its capabilities and its features. Now, if we have a glance at the right side of the screen, we can see this orange box, which showcases to us that fits multiple programs. So you can see we have domains covered like mechatronics, industrial maintenance, aviation maintenance, electrical, robotics and automation, renewable energy, mechanical engineering tools and technology. Then we have HVAC, that is heating, ventilation and air conditioning, marine technology, automotive, and so on. So this is the reason we say that Automation Studio software is a multi-technology software, as it covers each and every domain under single roof. So moving forward, what are the key benefits to students, teachers, and schools? So when it comes to students, so students can basically validate their theory studied in the class in much more interactive manner. And with that being said, the system's interaction will be highlighted in full color. So what do I mean by that? I will be explaining you this shortly. Now, when it comes to teachers, so teachers can basically facilitate the demonstration of systems interaction, which basically helps student to understand the critical concepts in much more lucid fashion. Okay. When it comes to schools, so school can basically eliminate the need to purchase single technology software, as Automation Studio software is a multi-technology software. So schools need not run behind a software for mechanical engineering department, for electrical engineering department, for robotics, for instrumentation. No, there is no need as such. So Automation Studio software suffices these many criticalities. Moving for moving forward. So over here, we also have one of the prominent feature, that is e-learning. So as we can see, Automation Studio License Manager is over here. So if there is any case like faculties want to assign a particular task to student, and that task should be completed within a stipulated amount of time. So for that reason, we can make use of this remote access e-learning platform. It is very much possible in Automation Studio software. So moving forward, when it comes to international presence, so we are available in 13 languages and in more than 150 countries. And Automation Studio software is basically used in high schools, career centers, colleges, universities, and workforce development. In front of you, we have a blueprint of the world map, so you can refer this. So when it comes to publications, as we can see, on the right hand side, if we have a glance, we have the pneumatic circuitry. Over here, we have made use of the pneumatic source. We have FRL unit, that is filter, regulator, and lubricator. Then we have DCVs, we have cylinders, double acting cylinders. And not only that, but also this particular circuitry we have taken into consideration from a publication labeled as Fluid Power with Application, written by Anthony Esposito. So in this publication, there are almost 600 to 700 pneumatic circuits as well as hydraulic circuits available. So we have basically pre-installed this publication, and not only this publication, but there are several other publications as well. So students just need to drag and drop the circuits from this publication, and it will be very much beneficial for them to understand like how the circuit is actually behaving in real time. Okay. So earlier I mentioned one statement like students will get to know about the criticalities of the circuit, and they will be able to understand the circuit as the components will be highlighted in dynamically full color. So what do I mean by that is, over here you can see we have red line and we have blue line. So the red line basically represents that the humongous amount of pressure getting acted at these particular lines, whereas the blue line represents considerable lower amount of pressure being acted. So in this fashion, student will get to know like at which segment of the circuit, like how is this behavior of the circuit at what segment. So say for an example, we take into consideration this segment. So over here we can see the high amount of pressure getting acted. So this will basically uh, be more clear to students like how the basic circuit is functioning. So moving forward, we have another prominent feature, that is interactive exercises. So over here you can see on the right hand side of the screen we have this hydraulic circuit. So we have taken into consideration the components like hydrostatic multi-port reservoir, then we have a universal directional pump with a drive mechanism, then we have DCV, pressure relief valve, and so on. So faculties can basically assign students a task such as to calculate the load acting on the cylinder, the piston diameter of the cylinder, what will be the rod diameter, what will be the stroke length of the cylinder. And once the student calculates these mathematical calculations, he or she can basically rectify their mathematical calculations with the help of Automation Studio software in such fashion. And not only that, but adding to it, over here we can see we have the green HMIs buttons like green, red, and blue. So these buttons can also be made use while creating a circuit. Okay. So if we have a glance at a left hand side of the window, so we can see we have the MCQ type of questions, we have descriptive type of questions, and not only that, but also we have the flowchart type of questions. So it is very much possible in Automation Studio software uh, for faculties that they can make use of any of these three options available to them. And further, students can basically create their own interactive exercises, and also they can easily customize those circuits. So moving forward, here we have the digital twin of your own equipment. So you can see we have the electro hydraulic trainer kit available in front of us, and behind the screen we have the Automation Studio software. So you need to just make the connections with the help of jumper wires that we have. in the electrotechnical in the electro hydraulic trainer kits. So once the connections are made, and once you establish a connection with the help of OPC, that is Open Platform Communication. So on the one hand, you will be having the Automation Studio software. On the other hand, you will be having the electro hydraulic trainer kit, and the intermediary bridge that will be acting will be of OPC connections, that is Open Platform Communication. So once you try to simulate your circuit, and if you try to shift the spool position of the DCV, so your cylinder will actuate in Automation Studio software, and same will be reciprocated in the electro hydraulic trainer kit. And adding to it, this will basically ease the transition from theory to practice. Like students will get to know like how the real components look like in real life. And adding to it, students can basically change the properties or create faults for troubleshooting segment as well. So moving forward, when it comes to the libraries, that is illustrated libraries. So you can see we have domains covered such as PLCs, hydraulic, AC/DC motor control, and pneumatics. So this particular library, the main motive behind upbringing of this library is to get to know like how the components will look like in real life. So as we can see, we have the Siemens Simatic S7 1200 PLC over here. So it will be very much beneficial for students to get to know like how this component looks like. And not only that, but also we have the reservoir, we have pump, we have gear pump, we have motor drive mechanism, we have DCVs, FCVs, cylinders, and so on. So students will be basically industry ready. Okay. So when it comes to AC/DC motor control, like we can see, we have multimeter clamp, we have three-phase asynchronous motor, and so on. So in Automation Studio software, you have basically three ways to create, simulate, and troubleshoot your circuit. What all are the three ways? The one being symbols, the second being illustrated components, the third being virtual trainers. I will be showcasing you all these three components in today's webinar. So here we have a short video for your reference. So I will play this video. So you can see the person is trying to make connections of the DCV to cylinder, which is a pneumatic trainer kit. On the left hand side, we are basically having a pneumatic trainer kit, and on the right hand side, we are having a pneumatic virtual trainer kit, which is nothing but the Automation Studio software. So the person is trying to make connection. He's connecting DCV to the cylinder with the help of pipe or hoses. Okay. The same connection I would like to showcase you on the right hand side. If you have a glance, the same connection is being made with the help of Automation Studio software. So the main motive behind showing this video is like it is very much possible for you to connect the hardware with the Automation Studio software. Okay. So moving forward. So what are some benefits of virtual plus hands-on experience? So as we can see, we have bifurcated the screen into two parts. On the left hand side, we have hardware only, and on the right hand side, we have hardware plus Automation Studio software. So when it comes to hardware only, it is comparatively much more expensive option, as the schools need to invest much in the hardware part. So over here you can see we have three hydraulic and electro hydraulic trainer kits available, and adding to it, only two students will be able to perform their experimentational work. So when it comes to on the right hand side, we can see hardware plus Automation Studio software. So we have two hydraulics and electro-hydraulic trainer kits available, and we have 20 user licenses of Automation Studio software with all modules. So it is comparatively cheaper option, like less expensive option. And adding to it, like students can also change properties of components to illustrate the different scenarios. Like they can change the pressure setting of the cracking pressure of the pressure relief valve. They can add certain external load to the cylinders and so on, which is comparatively more troublesome when it comes to the actual hardware only part. And further, We also have the ISO symbols, that is International Standards Organization symbols, which will enhance the blueprint reading skills of the students as well as faculties. And this also introduces students to circuit design software as well. So it will be much more skill addition in their uh, technical skill set. So moving forward, coming on to the available manufacturers catalog. So here we can see we have the various types of catalogs available, like we have Argo Hythos, we have Danfoss, we have Eaton, Bimba, Booker Hydraulics, then we have Bosch Rexroth, Parker, Oil Gear, and so on. From the electrotechnical perspective, we have Mitsubishi Electric and so on. So what basically is manufacturer's catalog? So over here, a manufacturer's catalog is nothing but a pre-configured, ready to simulate components that are readily available in the online catalog of the Automation Studio software. And over here, we can see we have this particular, say for an example, this axial piston pump from Parker. So you can see what all are the technical parameters that are taken into consideration from the industrial perspective. So over here we have displacement, moment of inertia, minimum pressure, minimum angular speed, minimum temperature, and what will be the weight or mass of the object. Okay. So these many technicalities are taken into consideration from the industrial perspective, and students will get to know about these many technicalities once they work upon the manufacturer's catalog components. And not only that, but also on the left hand side, you can see we have the DCV, which is pilot operated DCV from the Bosch Rexroth. Okay. So students just need to drag and drop these components in the Automation Studio software and they can work upon that particular component. So with that being said, here are some partial list of our industrial clients. From aerospace, we have Airbus, Boeing, NASA. From agriculture, we have AGCO, CNHI, John Deere. From energy, we have ABB, Orano. From forest, we have John Deere, Kubota. From construction, we have Caterpillar, Hitachi. Defense, Larsen and Toubro, JCB Defense. Metallurgy, we have China Steel and US Steel. Then from mining, we have Epiroc, Komatsu. From offshore, we have BRMS, El Nusa. Transport, Honda, Denso. System integrators, we have RV Hightech and Womack. From handling, we have Skyjack and Terex. Okay. So we are done with the corporate presentation. Now I would like to showcase you some features of the Automation Studio from the perspective of electrotechnical. So quickly opening the Automation Studio software. So I hope the screen is visible to you of the Automation Studio software. So over here, like you can see, this is the user interface of the Automation Studio software. On the right hand side, we have the Project Explorer. So I will click on this new project and you can see we have the welcoming screen of the Automation Studio software. Over here, we have Fluid, Electrotechnical, PLC, other technology, and educational templates. So say for an example, if I double click on the educational templates, so you can see we have hydraulic, pneumatic, instrumentation and process control, electrical, one line, electrical, PLC, and lastly we have robotics. So as of now, I will click on the default. And then over here on the left hand side, you can see we have the library explorer in which different sort of libraries are arranged. Like we have hydraulic, pneumatic, drive and transmission, environment and control, instrumentation and process control, electrical control, JIC and IC standard, digital electronics, ladder diagram ranging from Allen Bradley, IC Electric, Siemens, LS Electric, Mitsubishi. Then we have electrotechnical IC and NEMA, blocks, HMI, and robotics. So firstly, I will just create one document over here by clicking on the new. I will go in the electrotechnical diagram. I will say default. Once this is done, I will just click over here in the electrical control JIC and IC standard. So firstly, we will be dealing with the circuit building for DC circuit, and then we will move on to the AC circuit. So for DC circuit, I will go in the electrotechnical IC standard. So you can see it is this easy for you to just drag and drop the components. Okay. So you can see these many options are available. Like I want resistor, then I want another resistor to be attached in series. Then I want one voltmeter to check the voltage across the resistor. And also I will be needing one ammeter as well. So once this is done, I will just try to make connections by connecting the ports, the red ports. So the line that you're currently seeing is not just a CAD line, it's actually electric wires. I will complete the whole circuit in such fashion, and then as I want to measure the voltage across this resistor, so I am connecting it across this resistor voltmeter. Once the connection is done, we are ready with our circuit. But before moving with the simulation part, I would like to showcase you the data properties of the components. So you can see I have resistor. So if I go in the data property, you can see the resistance, that is, as of now it is 1000 ohms. So I can decrease it to 100 ohms as well, depending upon the requirement of the customer, client, or experimentational work. And also we have temperature coefficient, we have tolerance, we have rated temperature, maximum power, maximum resistance, what should be the maximum voltage. So it basically depends upon your discretion, like what you are expecting from your circuit. Okay, so this is how you can make use of these many technical characteristics. So if I close this, now if I try to simulate the circuit, so you can see the resistance that we can see over here is 100 ohms. Now I just clicked on this particular resistor and it is showing me resistance value, but I'm clicking it over here, but it is not showing me. So why this is the case? So I will double click on this. I will go in the parameter control. I will click slider. Once done, now I will try to simulate the circuit. So you can see earlierly it was showing me the slider control, and if I click on this, it will showcase over here as well. So with that being said, I would also like to showcase you like how you can measure certain properties, okay, with the help of measuring instruments as well. So if I go in the component dynamic measuring instrument, say for an example, I want to measure the current, that is a TRMS current across this particular wire. So I will press click, and say for an example, I want to measure the voltage or average current, say for an example, and I want the display unit to be in milliamps. So I will say milliamps, and I will increase its precision to 0.01, and I will press tick button over here. So you can see it is reading value of 21.94 milliamps as of now. And now what I'll be doing is I will be changing the value of resistance over here. So just have a look over here, the TRMS voltage, it will change. So as you can see, if I increase it to 20 ohms, so we can see we are getting a reading of 0.5 voltage. And let's say I increase it to 80 ohms. So you can see my voltage has increased to 1.8 volt. And same is the case over here. As of now, its resistance is 1000 ohms, so it is giving me value of reading of a voltage as 22.3 voltage. And same if I decrease it to 50 ohms, you can see there is a increase in the current, that is 185.59 milliamps, and it also increased the voltage from 9.3 voltage. So this is how you can basically make use of the DC circuits. With that being said, also I would like to showcase you multimeter clamps, like how you can make use of multimeter clamps. If I switch it on, so just drag and drop this particular component over here. So you can see I'm getting a value of 186 milliamps. And let's say I don't want to measure the amps, I want to measure voltage. So I will take these probes, attach it in such fashion. I want to measure it across this, and I will shift to amps. So now you can see it is giving me approx value of 186. And if I move it over here, the throughout 186 milliamps is getting recorded. And also we are getting a voltage of 9.28 volt across this particular resistor, that is RA2, which is of 50 ohms. So in this fashion, basically students will get to know like how the multimeter clamp works in real life, how you can measure certain properties, how you can denote the ammeter reading, voltmeter reading, how you can make use of the voltmeters, ammeters, how you can basically create your own circuit using resistors, how you can increase or decrease the value of resistors, and so on. So with that being said, I would also like to showcase you some plotters that we have in the Automation Studio software. So you can see this is the YT plotter. I will just drag and drop the resistor, the component that you want, across this line. So I will just drag and drop this line. I want to measure the TRMS current, and also I am supplying a voltage of 24 volts. So I will drag and drop it over here. Now, as soon as I will try to simulate this circuit, so you can see the values are getting changed in real life. So this is how basically you can plot your own graphs in Automation Studio software. Okay. So we have one yellow line and one blue line. So if you want to display legends, it is also very much possible in Automation Studio software. So our yellow line represents the TRMS current, and blue line represents the voltage. So voltage is constant over here and the current is getting fluctuated as we are increasing and decreasing the resistors. So this is how you can basically create your own YT plotter, and not only that, but also you can copy this YT plotter. I will showcase you how to copy. So over here you have the option of copy plotter image. I will close this and I will paste it over here. So you can see it will be very much beneficial for students and faculties if they want to create their own reports. So they can attach these images in the reports as a case studies as well. So this was regarding the circuit building, using measuring properties, and also using multimeter clamps. And also we have seen the YT plotters. So this was regarding the DC circuit. Now I would like to showcase you regarding the AC circuits, like how you can make your AC circuit. So I will go in the electrotechnical IC. Now I want three-phase connection. So I will just drag and drop these three-phase. I want one thermomagnetic circuit breaker. Then I will be needing one fuse, that is 3 poles NO contact group. So I have this 3 poles NO contact group. I will denote it as CRN01. And then I will be attaching one three-phase asynchronous motor at the output end. And then I will be requiring one transformer. I will be requiring one fuse switch with 2 poles. So I will just expand this library. I will go in control, protection, expand this control under protection. You can see I have fuse. So I will choose this fuse with 2 poles. Then I will be needing one push buttons as well. So I will take this normally open push button. I will change its orientation by pressing Ctrl H button, shortcut key. And then I will be requiring one AC/DC coil. So for coils, you just need to go in the AC/DC contactor coil. So I will go in the contactor coils. Here we have AC/DC. I will just drag and drop. And yes, we are done with the circuit. Just need to make connections now. So you have one option over here that is of polyphase wire. So what you can do is make use of polyphase wire to connect these 3 terminals at a single time, that is simultaneously. Okay. So once this is done, I will give this connection over here, and this connection I will give it over here. So we are done with the circuit. Now only one thing we are left off with is linking the contactor coils with this particular 3 poles NO contact group. So for that, I will go in this particular double click on this particular component, select KF1. It will ask me the group 1 will be transferred. Press OK. Once this is done, now you can see it has hyperlinked. So I will just make use of one transmission shaft over here, and I will make use of this particular wheel in order to rotate this particular wheel. And I will also make use of multi-gauge, mechanical multi-gauge. I will drag and drop this component. I will press Ctrl R to flip it vertically. So you can see it is done. Now I will try to simulate my circuit by going in the simulation tab, normal simulation. So once this is done, I will activate the circuit breaker. And as soon as you can see, if I press this start button, this coil will energize, and this will send the signal to this particular 3-pole NO contact group, and it will also try to rotate my wheel. So you can see it is working fine. Not only that, if you have a glance over here, it is recording a value of 1471.1 RPM, that is rotations per minute, with 1 decanewton meter torque getting generated and 2.4 kilowatts of energy getting consumed. So this is how basically you can create your AC circuit and DC circuit. Adding to it, you can also make use of the measuring properties. And it will be showing you the power consumption. Also, you can make use of the node selection method, and it will be showing you the voltage, that is 399.74 voltage is getting generated, as we have the source of 400 volts. So this is how you can create your own AC circuits as well as DC circuits. Now with that being said, we will be moving with the further part, that is of PLC, Mitsubishi PLC. So I will just create a new project. So you can see I have this particular workspace, and I will be dragging and dropping one PLC. So for PLC, what you can do is just click on this particular open library, that is orange icon. You will find one section of PLCs. You can see over here, PLC. Just click over here. And as of now, I will be using one Mitsubishi PLC. So you can see we have these many PLCs available, like Allen Bradley, then we have Bosch Rexroth, Eaton, Koyo, LS Electric, Mitsubishi, Omron, Schneider, and so on. We have Siemens as well. So as of now, I will be going with the Mitsubishi. I will be clicking for the standard diagram. I will just drag and drop. So you can see I have just dragged and dropped, but I will do one more thing. I will click over here, press on the new. I will choose electrotechnical diagram, as I need to make connections with the help of switches. So switches won't be able to drag and drop in the standard diagram. So I will close this. I will delete this. Yes. I will just drag and drop it over here for electrotechnical. I will expand this. So I have dragged and dropped the component. Now I will be going to generic components, and over here I will be choosing electrotechnical IC. Under IC I will be going, let's say I go in this library, that is electrical control North America residential. So over here we will be having options such as switches, lights, photosensors, and so on, outlets. Okay, it is not getting dragged and dropped. So I have one file for you. So over here, like you can see, we have basically dragged and dropped the Mitsubishi PLC. And not only that, but also we have made use of the source voltages. It is phase and neutral. Then we have made use of switches. Then at the output end, we have the bulb. So if I go in this particular North America residential, so you can see over here, you will be finding the AC source. You just drag and drop this AC source. And also you can just drag and drop this particular phase and neutral. And then under switches tab, you will be finding this particular switch. So we have lamps. So from lamp over here, I just drag and drop this lamp. And similarly, I have just dragged and dropped the switches as well. Okay. So with that being said, I will just try to simulate the circuit. I will delete these components that are not required. So over here, like you can see, we have created ladder diagram as well. So we have this normally open push button, which will be acting as switch. And at the output, I have basically linked the bulb. So if I try to simulate the circuit, I will go in the simulation tab. I don't require this multimeter clamp, so I will switch it off from over here. I will just drag and drop. And as soon as I press the switch button, so you can see my uh, bulb should glow, but it is not glowing. So there might be problem with the PLC configurator. So I will just go in the ladder diagram. I will go in the PLC configurator. I will go in input output. So over here, I will just have a look. It is SWT. So I will label it over here as SWT. Okay. I will close this. Now it is SWT. I will again go in the PLC configurator for confirmation. Yes, it is SWT X0 and at Y1 it is output. Perfect. Now it should work. So I will try to simulate my circuit. Now you can see my bulb is glowing. So this is how basically you can create your own logic with the help of Mitsubishi. And not only that, but also make one thing sure that the connections that you are giving, like over here, X0, X1, which will be an digital input, and at Y0, Y1 will be your digital output. And adding to it, like you make sure that you have connected the phase wire to the live connection and neutral to neutral. And you just need to make sure that one more thing that you have shot this particular circuitry over from over here. So once you do this, your circuit will be in ready condition. And not only that, but also you can add several other bulbs as well, or fan, say for an example, and you can try to simulate your circuit with the help of PLC, Mitsubishi. So this was the part regarding the Mitsubishi PLC. And so far we have what we have covered is we have looked into DC circuits. We have made use of the measuring properties, measuring instruments. Then we have seen the YT plotters. Then we have seen multimeter clamps. Then we switch to DC circuits and DC circuits, wherein we have made use of the transmission shaft, motors, thermomagnetic circuit breakers, and so on in order to run our DC circuit. Then we came to Mitsubishi PLC. We saw like how you can make use of the PLCs in order to configure your circuit and also run your circuit with the help of ladder logic over here. So these are the topics that we have covered so far. Now I will be showcasing you a virtual trainer kit. So I will click on this control new, that is a new button, new project. So I will click on the educational template. Over here we have electrical. I will go in the virtual trainers. So you can see you have these many options available, but right now we will be going with the North America. And in this, I will be showing you an example of ceiling fan, like how students can make connections, like how they will connect the ground wire, the live wire, the neutral wire, and so on. Okay. So you can see, just have a brief overview. We have this ceiling fan and we have this bulb and we have two switches. And the main agenda over here is if I press this switch one button, my ceiling fan should run. And if I press this switch button two, my light should glow. So trying to make connections over here. So we can see we have this particular live wire I will try to make connection to connecting it with L1. Then I have this neutral. I will connect it with N. Then I have this ground. I will connect it with ground. Once this is done, I will make connections over here for switches now. So I will give connection to ground first, and this also to ground. This live wire, I will connect it over here, and this live, I will connect it over here. So you can see we have made connections for both the switches. Now it's time for us to configure the ceiling fan. So making connection for ceiling fans. So I will connect it over here, ground. Again, one ground over here. This neutral, I will give it to over here. The live wire connection should be given to the black one. The remainder red. Connected in such fashion, and what we are left off with is the neutral wire. The connections have been done for the ceiling fan as well. Now we will focus upon the bulb. So for bulb, I will be requiring one connection to be made over here, the neutral to be connected over here, and the ground directly to over here. So we are done with the connections. Now I will zoom all components and I will try to simulate the circuit. So you can see if I press the switch button 1, my ceiling fan is rotating. And if I press this push button 2, my bulb, which is of 60 watts, should glow. And you can see my both of the connections are correct. So both of the equipments, both of the appliances are working fine. So this is how it will be very much beneficial for students, like they will understand like how the connections are to be made when it comes to real application oriented projects. Okay. So far, if you have any questions, you can please post your questions in the question panel. We would be happy to address all your queries. So this was regarding the virtual trainer kits. And further, we have one more segment left, and that is of illustrated components. So what we can do is I will create one new document. So I will go in this orange icon over here. I will choose one illustrated electrical components now. So we have this motor control renewable energy. I will press tick. So now you can see we have the drive and transmission elements. We have transmission, we have measuring instruments, we have renewable energy, charge controllers, energy sources. We have batteries, photovoltaic cells, mono and poly, then wind turbines, then ambient sensors, inverters. Then we have motor control and so on. Like we have also have sensors, lamps, relays, timers, and drum switch, buzzers, potentiometers. So as of now, I will just make a quick circuit for you. Like I will be using one battery source. It is taking a time as I have opened multiple documents over here. So you can see if I go in the motor control over here, under power, if I expand this power library, you can see we have the energy sources. I will expand this energy source. I have battery, and under battery, I will be choosing 24 watt or 24 volts. So I will create one electrotechnical diagram and I will drag and drop. So you can see it is this much easy for you to just drag and drop the components in the Automation Studio software workspace area. And then I will be needing one voltmeter as well. So for voltmeter, I will be going in the measuring instrument part. So here we have measuring instrument. I have this voltmeter, then I have this another voltmeter, and then I have one ammeter. So once this is done, I will make my rheostat over here. So for rheostat, I need to go in the passive components. So once I click over here, passive components, you can see we have the resistor with movable contact. So I will just drag and drop it over here. Once this is done, now I will try to make connections. So for connections, like you have these many options available, whether you want to go with the control wire or so. I will be going with the curved wire. So I will connect the positive terminal of the battery to the negative terminal of the ammeter, and the negative terminal of the battery to the rheostat's positive terminal. And same applies with the voltmeters positive terminal to the rheostat positive terminal. And then this will go over here. Once the connections are done, I will simulate my circuit. So you can see it is reading 12.1 volt, 12.1 volt, as the resistor's opening is 50% and supplied voltage is 24 volts. So I will decrease this. So you can see as soon as I'm decreasing the resistance value, my voltage is also getting decreased. Okay. So if I try to increase the resistance value over here, my voltage value is getting increased. And similarly, you can see the effect on the current, that my current is decreasing as I'm increasing the resistance. And as I'm decreasing the resistance, my current is increasing, as it is inversely proportional with respect to Ohm's law. That is, voltage is equal to current times resistance. So in this fashion, like students and faculties can get to know about the working of the systems interaction in electrotechnical circuits. So this was regarding the illustrated component circuits. Now there are certain files that I would like to showcase to you. If I go in the catalog manager, so if I go in the demonstration part under electrotechnical automation part, so you can see we have this example of stepper motor. So I will try to open this circuit over here. Stepper motor for car windows, car power windows. So you can see we have this example of car power window. So we have this stepper motor attached over here, which is currently representing 0 degree. And we have certain relays, we have certain battery sources, inputs. Then we have stop button, start button, switches, and so on. And over here, you can see these are nothing but the LED displays. And to the right hand side, we have the battery source of 24 volts. So I will try to simulate the circuit. So not only this, but also you can see we have created certain hyperlinks which we have linked with the ladder logic over here. And adding to it, we have made use of certain timers, counters over here, as you can see. So if I try to simulate the circuit now, if I press this forward button, so you can see my car power window is moving in downward direction, which has been successfully energized with the help of the stepper motor. So earlierly you can see it was 0 degree, but currently you can see the value as 55.8 degrees. Now if I try to uh, I want to reverse the direction of the power window. So what I can do is I can press this button, and you can see the power window is getting back to its normal position. So in this fashion, like you can create your own circuit, and adding to it, not only your circuit, but also you can create your CAD in the Automation Studio software in such fashion. So with that being said, I have another example for you. So this is basically an electro-pneumatic circuit. Like we have made use of the electrical part as well over here on the right hand side, and we have made use of the pneumatic part as well on the left hand side. And adding to it, we have also drafted the 2D HMI over here in the bottom left corner. So if I play this video, you can see as soon as the main lever is in a switched on position, my uh, cylinder will try to extend the object, and this particular cylinder will try to grab the object and place the object onto the conveyor. So this is how basically you can integrate domains like hydraulics, pneumatics with electrical in order to create electro-hydraulic or electro-pneumatic circuits as well. So we have VFDs as well, that is variable frequency drive. Then we have servo motors as well. And recently we have seen an example of stepper motor. So do we have any questions so far? So I have this one example for the drilling factory solution. Like we have made use of the PLCs. If I zoom all components, so you can see this is basically a simple example of if I press this start button. So you can see my pneumatic cylinder is trying to extend the object and the drilling operation is getting performed. So all this is taken care by the ladder logic that we have built over here. And if you want the ladder diagram, so it is available on the next page. So over here, as we can see, we have T on, that is timer on delay. Then we have drill on as the output coil that we are using as a memory coil, and so on. So I hope it is very much clear at your end, like how you can integrate the domains, not only from the perspective of electrical, but also from the perspective of hydraulics and pneumatics as well. So this was the last file that I would like to showcase you. So thank you everyone for your kind attention. If you have any questions, please feel free to post your questions in the question panel. Uh, I have completed from my side, and I will be waiting for more 2 minutes for your questions. Meanwhile, I will be sharing with you my mail ID, so you can just draft your questions if you have any questions, and we would be happy to address all your queries. So I hope my mail ID is visible to you. Just take a note of this mail ID, and if you face any questions in future, just please try to reach out me via this mail ID. So I can see so far no questions are there. So thank you everyone for your kind attention, for your patience listening. I hope it might have added some knowledge gaining session for you as well. So thank you everyone. Have a nice day. Yeah. And we do have one more webinar left on 30th of September. Please do register for the same. It will be for the robotics domain. Okay. Thank you.